Hello, I'm Nicolas 6 and I'm going to present my work named Decision Process for Blockchain Architecture Based on Requirements in the context of my doctoral thesis directed by Professor Camille Salinesi and Dr. Nicolas. So first of all, I'm going to introduce the thesis context. Then I'm going to talk about the BLADE project, which stands for Blockchain Automated Decision Process. Then I'm going to talk about our achieved work and conclude with our future works. Let's start with a recap of what blockchain is. We can see blockchain as a distributed database only accessible for reading and happening, and no central third-party authority is in charge. This is a trending topic for the academic community, as you can see on the left graph showing the increasing number of search results for the blockchain subject on Google Scholar, but also in the industrial community on the right graph. And as you can see, according to this Deloitte study, more than 50% of the interviewees say that blockchain will be critical for their organizations. In parallel, system architectures are evolving, getting more complex to add new components and technologies. But to address this, architectural patterns are created. But for blockchain, this is different because no field-tested pattern exists yet, and this raises many questions such as how to integrate blockchain into new or existing architectures. Can we integrate blockchain into most used architectural patterns such as microservice architecture? Or how to decide which blockchain and architectural pattern to use? We can find in the literature some related works to address issues mentioned before. For example, we can find decision model between blockchain to help the architect to choose whether using blockchain or not, and if yes, which one. We can also find automated decision process between blockchain and new architectural patterns that includes blockchain technologies. In this doctoral thesis, we want to go one step further by introducing an end-to-end solution for system architects to choose the most suitable blockchain and architectural pattern for a given case. And so from a set of inputs, the system architect will be able to get a decision from the automated decision process that take profit of a knowledge base also defined later in this presentation. And the second part will be the generation of architectural steps to ease the development of blockchain solution for system architects. But conceiving and implementing this project is not an easy task and raises many questions, such as how can we extract and structure the data of business processes, assets, and requirements? How can we process those data to make decisions regarding system architectures? What are the impact of blockchain specificities in the expression of the architectural model? And finally, how blockchain can be integrated into existing architectural patterns. To answer those questions, we are going to follow a design science research approach. This is an iterative approach because our work will be built by increments, and each step of our work will refine other steps. So for example, the knowledge base increment will refine the quality of our artifacts and vice versa. And this is also a quality insurance because each work will lead to an evaluation using case study, experiment, and interview. So each artifact will be validated at each step of this iterative approach. In the context of this methodology, we have three main points. First, we have the artifacts that represent our blockchain architecture generator and our automated decision process. Then we have the knowledge part, which is our knowledge base containing experiment, previous studies, our own studies, and also the knowledge of the BLADE project, which is the blockchain and architectural patterns formalized, refined by experiment and studies. And finally, we have an evaluation step, an evaluation part, containing case study, experiments, and expert interview needed. We are now going to talk more in detail about the BLADE project and especially its inputs. We are going to talk about the requirements. They can be entered as two types. Non-functional, so for example, the system should have a latency under a certain threshold, or functional, so for example, the user should be able to do a specific action. Each requirement is weighted between 0, so the decision process is indifferent to the requirement, N1. So the decision process is really concerned with the requirement and will take it more into account than any other requirement. And they can also be marked as mandatory. So for example, if you provide a value and the value is not reached by an architectural pattern, it will be automatically disqualified. The second type of inputs are enterprise assets represented by infrastructure mainly. And we expect the system architect to provide a network topology of the system already deployed, or also the available machines and their characteristic. Because, for example, the computation power of a machine could affect the performance of a blockchain and so alter the decision taken by the Blade project. And a third optional input could be the business process, because we could extract the inner logic of a business process to derive an architectural pattern. And also, we could have some specific non-functional and functional requirements for a given business process. So let's talk about the decision-making part of the Blade project. Here, the decision can be done using multi-criteria decision-making methods, such as TOPSIS. And we chose TOPSIS because it can process a lot of criteria, so in the future, we will not be limited by the amount of criteria. And also, it can process criteria on different scales and units. So for example, if we have one attribute in seconds and the other one in transaction per seconds, respectively for the latency and the throughput, we will be able to make a decision even if the units are different. And to make accurate decisions, the Blade project relies on a blockchain knowledge base constituted with blockchain and their attributes, and also the architectural patterns. So the knowledge base is the main component of our project, but how to keep it relevant and accurate? To do that, we are going to extract the knowledge of case studies, for example, about the system architecture or real-life use case, such as IoT or supply chain. We are also going to extract the knowledge of white papers and technical reports about blockchain and patterns. We are going to take profit of new blockchain studies, for example, about patterns and blockchain decision models. And finally, we are going to rely on experts to refine the attributes over the time, but also to perform interview, for example, to challenge them on a dummy use case to see how could they implement blockchain on this use case. Now I'm going to introduce our architecture generator that aims to ease the adoption of blockchain by industrial partners and shorten the time between development and production. This will be time saving and cost saving for companies, but also that will propose solid foundation to develop over. So from a blockchain Blade recommendation, we'll be able to generate architectural stubs. So for example, smart contract skeletons, API templates, and even logic functions. So far, we already have promising results. A fair version of the Blade project is publicly available on the net, and the source code is available on GitHub. It helps architects making decisions between using one of the 5 most used blockchain according to a research article. And the selection is made on 14 attributes. And we also built a blockchain benchmark framework. To conclude, this doctoral thesis will aim to build a decision process for blockchain architectures and a knowledge base of blockchain and patterns by increment following a DSR approach. This aims to get a better understanding about blockchain utilization and integration for system architects, a work that has direct industrial application. For the next step, we want to refine our artifacts by building an attribute feature model, improving the decision-making using fuzzy logic, and performing automatic benchmark when making some decisions. We also want to refine the knowledge base by performing research about blockchain architectural patterns and making a systematic literature review on blockchain and system architecture to get a better understanding on what have been done in the academic community on this topic. And we also want to validate iteratively our result by performing case studies, collaboration with companies to refine notably the knowledge-based content, and benchmarks. Thank you for your attention, and if you are interested by your research, feel free to contact me or read our associated paper. Thank you.